All right, in this third section, this is Chapter 2, Section 3. We're going to talk about isotopes and atomic mass. So we already talked about atoms of the same element having exactly the same number of protons, and if they're neutral, they have the same number of electrons, but they can actually have different numbers of neutrons. And so if they have different numbers of neutrons, they can have different mass numbers, because remember, we said the mass number is the number of protons plus the number of neutrons. Protons will always stay the same for the same element, but neutrons can change. The number of neutrons can change. And so if you have atoms that have the same number of protons, right? It's the same element, but they have different numbers of neutrons, then those are called isotopes, right? So isotopes have the same number of protons, but they have different numbers of neutrons. And so we can indicate it in one of two different ways. We can use a symbolic notation, right? Like we were doing before. Or you can do it with a name and then the mass number behind it. So I'm going to show you the same thing for all of them. So carbon 12, if we have carbon 12, well, it's carbon. So if you go look on the periodic table, how many protons does carbon have? Carbon has 6, right? If you looked on the periodic table, there's carbon, should have a 6 on the top. It has another number at the bottom, which we haven't gotten to yet, but we will. So right there on the top is the atomic number, and so that's what we're going to put there. And then it's telling us that we have a mass number of 12. So what this tells us is we have 6 protons and we have 6 neutrons. Okay, now what about carbon 13? So you do the same thing. It's carbon, so it must have 6 electrons, and then instead of having 12, a mass number of 12, it has a mass number of 13. Well, what does that tell us? It tells us in this case, we still have 6 neutrons, but in order to get to a total of, I'm sorry, I wrote that wrong. Oh my goodness, it's 6 protons, right? We know we have 6 protons, but because we have a mass number of 13, how are we going to get 13? We have to now have 7 neutrons, right? Next one, carbon 14. We know that it has 6 protons. So we're going to say we have 6, but how do we get to 14 for a mass number? We can't change the number of protons, so we have to change the number of neutrons. So that means we must have 8 neutrons. So you can write it either way in this symbolic notation, or you can write it out as the element and then a dash and the mass number. So when you look on the periodic table and you have carbon and it has 6, and then it has another number right down here, this number right down there is the average atomic mass for the element. And the average atomic mass depends on all the different isotopes and how prevalent each of the isotopes is in nature. So if you have carbon, for example, that has 3 isotopes, we have carbon 12, carbon 13, carbon 14, the mass of carbon is going to be an average of all of those isotopes, but it's a little more precise than that. It's a weighted average. And so the more you have of each one, let's say carbon 12, you have more carbon 12 than any of the others. So your average is going to be closer to the mass of carbon 12 than it is going to be the mass of carbon 13 or carbon 14. So let me show you what I mean. So here's the periodic table, right? We have carbon. We know our number of protons is 6 on the top. And here's our average atomic mass. So how do we figure that out? How do we get 12.01? Because if you had 3 isotopes of carbon, and one was 12, one was 13, and one was 14. If I wanted to get an average of this, I add all of these up. So 7, 8, 9, and I divide by 3, right? Because I have 3 of them. If it was a regular old average, that would give me an average of 13, would be a non-weighted average, right? But I got an average on the periodic table that's 12.01. Why? Well, here's the deal. You have so much carbon 12 that when we take this weighted average, which means we take the weight of carbon-12 and we say, okay, carbon-12 has a mass of 12 and it has an abundance of 99%. 99% of all carbon atoms are carbon-12. So in order to make this weighted average, I multiply by the decimal format of my percentage, right? Then I do my next one. Okay, here's carbon-13. So I'm going to take my mass and I'm going to multiply by the weighted average. Now remember, if it's 1%, we got to move that decimal place 2 times, right? So that gives me a decimal of 0.01. So 0.01 plus my carbon-14, right? It's like so tiny that we don't even do it. So like 0.0001, something like that. Really, really small. And then, let's scratch that out. And then we take that and we divide by 3. So that's why it's different. If it was a regular average, this is a weighted average. This is a regular average, right? A regular average would just be 12 plus 13 plus 14 divided by 3. So here I'm going to get 13, but here, if you put that into your calculator, you would get 12.01. So the weight of the element on the periodic table is more dependent upon carbon-12 isotope than any other isotope. So the closer the atomic weight is to the mass number of an isotope, the more prevalent that isotope is. So I know that carbon-12 is more prevalent than any other carbon isotope, right? Okay, so let's go do some problems real quick. All right, so we're gonna do this little inquiry thing, discovering the concepts, right? Okay, so we have 2 atoms here. They are both isotopes of calcium. And so we're looking at the number of particles in each. So inside the nucleus, we have 20 protons and we have 20 neutrons. And inside the electron cloud, we're not doing them as dots anymore. We're just saying, okay, here's the cloud. We have 20 electrons. So if we write that, we write our mass number on top, mass number, which is our neutrons plus protons, right? And then we have our atomic number here, which is our number of protons and also our number of electrons, right? And then the same thing, we have the same thing, except we have a different isotope. So this is calcium-42 on the side. Calcium-42 has the same number of protons, 20 protons, 20 electrons, but it has a different number of neutrons. So this is neutrons plus protons, right? Okay, so let's go down and answer some questions. How many protons are found in calcium-40 and calcium-42? It's 20 because it's calcium, right? If we go up to our periodic table and you go and you find calcium, here's calcium. It doesn't matter what isotope you are. That 20 tells me I have 20 protons. So I'm going to go and come back here and I'm going to say how many protons are found in calcium-40? 20. How many are found in calcium-42? 20. If it says calcium, the answer must be 20. Must be. How many neutrons are found in calcium-40 and calcium-42? So neutrons, if you want to find neutrons, right, we take our mass number and we subtract the number of protons. So for calcium-40, our mass number is 40 minus our number of protons, which is 20. So our number of neutrons is equal to 20 neutrons. So we're going to say that's 20. That was terrible too. 20. Okay. Now how about calcium-42? It's the same thing, but this case we're doing 42 minus 20. So that gives us 22 neutrons. Okay. What is the relationship between the number of protons and the number of electrons in an atom? And I'm going to say in a neutral, because we'll talk about charges later on. But they are equal, right? They are equal. P plus equal to E minus. Based on the information, what is common to all calcium atoms? Well, they all have to have the same number of protons, right? Or they're not calcium. And therefore, they all have the same number of electrons. All right, so now 5, what could the atomic number Z indicate? So here, what could that indicate? What could that call? That could be our number of protons, right? Now, how's the mass number A found? Well, in general, we're saying the mass number is right here. And so in general, how do we find that? We take our number of protons and we add them to our number of neutrons and we get them, right? So from the information given, how would you define an isotope? So it's atoms of the same element with different numbers of neutrons, neutrons, if I could spell. All right, where are the protons, neutrons, and electrons located within the atom? Protons and neutrons are in the nucleus. And then the electrons are in that big cloud. So remember, we call that the electron cloud. So what do all calcium isotopes have in common? Well, just like a calcium atom from number 4, all calcium isotopes have same number of protons, and number of electrons. How do they differ? They differ in the number of neutrons, right? So where's the mass of the atom? Well, the greatest mass of the atom is in the nucleus, right? Because that's where the protons and the neutrons are. Remember, electrons don't have very much at all. All right, last one. For the following isotopes, determine the number of protons, neutrons, and electrons. Well, if we look here, this 9 is telling us our number of protons, which also tells us our number of electrons. So now you just need to subtract the 2 to get our number of protons. So 18 minus 9 is 9. Okay, fluorine on the other hand. Fluorine, we have, see it's the same 9, it's a 9. I kind of wrote over that right there, okay? So we have 9 protons, 9 electrons, but now our mass number is 1 more, so that means we have 1 more neutron in fluorine 19 than we do in fluorine 18. And that is the end of that one. We'll do the rest in class. Okay, y'all have a great day.